Welcome back to Problem of the Day. Here's today's challenge. Pick 3 vertices of a regular 2n plus one-sided polygon at random. What's the probability that the triangle they form contains the center? Let's begin with a regular 7-sided polygon. We'll first understand the idea here, then generalize to any odd 2n plus one-sided regular polygon. First question: how do we even locate the center? From geometry, we know that the center lies on every line of symmetry of the polygon. So if we draw 2 such symmetry lines, their intersection, bingo, that's our center. Now, here's the clever part. A symmetry line slices the polygon into 2 equal halves, perfect mirror images. Let's zoom into just the right half. Suppose we fix one vertex, say V1. If we now pick the other 2 vertices both from the remaining vertices on this same side of the symmetry line, the triangle will be trapped entirely within that half. And guess what? It will never contain the center. That's the golden insight. A triangle misses the center if and only if all 3 of its vertices lie within the same semicircle of the polygon's circumcircle. Now let's count such triangles. First, we choose the fixed vertex, the one that lies on the line of symmetry. That can be done in 7C1 ways. Next, we need to pick the remaining 2 vertices from one side of the symmetry line. On the right half of the polygon, there are exactly 3 such vertices, so the number of ways is 3C2. And of course, the same count holds for the left half of the polygon. So we multiply by 2. But wait, we've double counted. Each triangle gets counted twice in this method. Let's see how. Look at the triangle V1, V2, V3. We counted this when we took the line of symmetry passing through V1. But if the line of symmetry passes through V3, we get the exact same triangle again. So, every triangle is counted twice in our method, which means we simply divide by 2 to get the correct number. So we'll divide by 2 and end up with 7C1 into 3C2. Now let's generalize this for 2n plus one-sided regular polygon. Number of such triangles equals to 2n plus 1c1 for fixed vertex into nc2 for rest of 2 vertices. Now multiply by 2 for both halves and finally divide by 2 for double counting. So we get 2n plus 1c1 into nc2. Now number of triangles containing the center is equal to total number of triangles minus number of triangles not containing the center, which is 2n plus 1c3 minus 2n plus 1c1 into nc2. Finally, the probability is obtained by dividing the number of triangles containing the center by the total number of triangles. Substituting the values, we arrive at this. So, that's our final probability. If you enjoyed this problem, don't forget to like, share, and subscribe for more such interesting math puzzles.